Welcome, everyone. We're here to learn about methane area baselines, what they are, how they work, why they're important. And there'll be 2 introductions first, and then we'll have 2 presentations, and then there'll be time for your questions. And then after that, anybody interested can also speak with Bryce Payne additionally. So, let's start out with our wonderful neighbor, Tricia Lessig, who's going to tell you a little bit about how she got involved. Trish is the producer of Gasland and Gasland 2 and other media extravaganzas of various sorts, and has had a house in the town of Delaware since 2002, which is very close to her heart. And so I'll turn it over to Trish.
So thank you so much for coming on this beautiful day. Barbara and I have been working on getting this report together for the last year. And as she said, in 2002, I bought a home in the Lower Beechwoods, and I immediately fell in love with this area and was having the time of my life here. And never imagined that I would ever have to be worried about anything in my community, that it's just this most bucolic setting, and I assimilated well and was having a great life here. And then I suddenly heard that there was a potential for natural gas drilling to come to our neighborhood. And my instincts were telling me something about what the industry was claiming somehow was too good to be true. So I started to do research. And in that research, I stumbled across Damascus Citizens for Sustainability. And in 2008, in this very room, I came to a meeting where I heard Barbara Arundel share with us the dangers of fracking and also introduce us to Dr. Theo Coburn. And I was immediately interested in doing more to educate and to empower. And I want to thank Joe Levine and his wife Jane, because they were pivotal in getting Gasland 1 and 2 made, because they brought Josh Fox and myself together. And that, for me, was always my career dream, that I would be able to be a part of filmmaking that would have an impact and that would make a difference for not only just in our backyards, but nationally and now internationally. So Josh and I did both Gasland 1 and 2, and I imagine most of you have seen the films. Barbara, during the making of Gasland 2, Barbara started to tell me about methane baseline testing. And from what she said, the assurance of having a report like this is kind of like an insurance policy for our town, because it'll reveal to us what our current levels are, so that if gas drilling ever should come, we can have a before and after analysis that will give us something to chew on if we ever have real damages in the environment and we need to take it to a more official level. And this report will be filed with the town officials. It's been given to the local media, and also you can get a copy of it today at the end of the meeting. I also want to emphasize the incredible commitment DCS has made, not only to me, but to so many of us, and to Josh, and to this whole movement, because I don't know, without them, if I had met them, I would be standing here today and we would be in the position we are in this state. Also, Wes Gillingham is here from Mountain Keeper, and I want to acknowledge him too, and he and Ramsey and all of the organizations that have come together have had a pivotal impact. So anyway, Barbara told me about the testing, and I immediately said, could you help me find a way to have it done in the town of Delaware? And her fierce commitment is always so unshakable, and she said, okay, well, let's work on that. So we were valiant in raising some funds for the report, but not completely successful. And DCS was generous enough to lend us funds to complete the study. However, it would be really remarkable today if you would consider a donation to help reimburse the cost of the report, because it was pretty substantial. And they're very good to make loans. They also have a lot of other projects they're doing. At the end of the session today, if you feel inspired by the report and see the value in it, if you would consider a contribution, we'd be really grateful. So on that note, I'll turn it over to, I guess, Barbara, you're going to say a few more things, and thank you again. Appreciate it.
As for the context of how we wound up doing a baseline in the town of Delaware. We wanted to know what the other side of the river from Damascus would look like. And from Bob Ackley's presentation, who you'll see next, he asks, what is a methane baseline? It's a collection of methane data that enables specification of a normal range of methane levels for any given location in a methane data set. Now, what does that mean? That means the normal conditions of an area. And you're going to learn a lot about what is methane and how it comes and goes and so forth in this presentation. From my own personal perspective, I wanted to make these baselines happen. When I learned about the technology, it made a lot of sense to use it to record the existing conditions, the normal range of methane levels, as Bob clearly says, over an area that is intact and has not been drilled. So we raised money to start with the Damascus Township, in part because the largest leaseholder in the upper Delaware Basin was the Hess and Newfield agreement, which covered 170,000 acres, and about half of that was in Damascus Township. So by rigorously baselining the town of Damascus, we actually made an impact. The industry did notice, and industry media did cover the baseline being done. Hess and Newfield have since withdrawn from the area. So why do it? It's to protect. It's for economic reasons and possibly preemptive, but definitely with a firm protection of value, and it establishes what you have now. And I agree with Beth Radow, who describes herself at New York Senator Avella's hearing in February this year as a lifelong New Yorker, a lawyer, and a mom. She says, the impacts of unconventional shale gas drilling or fracking on home ownership, risk allocation, and mortgages has been published in various law journals and sourced and cited in publications such as the New York Times, Huffington Post, and More magazine. Across America, property ownership is being revolutionized by the proliferation of multi-step heavy industrial drilling operations on the land surface and subsurface of private homes and farms. The control of land with drilling operations is being overtaken by the gas developers with potential long-term impacts to property value. The oil and gas industry asks that we consider the benefits of frack gas, and I ask that you consider the costs and expenses. I and others outline today and do the math. When it comes to our children and our magnificent planet, there is no margin of error. This is where accurate, and now that was a quote from Beth Radow, a lawyer and researcher on mortgages and insurance impacts of fracking. In Pennsylvania, the PADEP information says that approximately in 2012, almost 9% of the wells fail immediately. And of course, over 50 years, they fail, almost all of them fail. And this is what it looks like, which you'll see in the presentations in the Wyalusing area. In one little corner of this, actually I think it's this corner, in Terry Township, there was a settlement of $1.6 million for Chesapeake's damage of 3 homes. Of course, there were 3 families and 2 law firms, so they barely got enough to get out, but they did get out without a non-disclosure agreement in the settlement. But the impact of the whole area from being drilled is tremendous. So that's where the baselines come in. Water, air, stream, and land sampling, even human medical blood and body tests are all extremely important, but the simplest to get done is ambient air methane testing, done on public roads and requires no permissions and is strong and accurate information and is admissible in court material. So what you're going to learn about today is what our attorney, Jeff Zimmerman, says about baselines. The importance of this issue to industry is obvious from the effort it invests in creating legislative presumptions that help insulate it from liability, such as the presumption provision in the Pennsylvania Oil and Gas Act. Along with this specious job creation and energy independence claim, the third leg of industry's investment in millions and millions of dollars in advertising is its assertion that fracking has never contaminated drinking water. Because the industry cannot prove scientifically that fracking has not caused contamination, it has relied on exemptions and presumptions to limit its liability. Factual information establishing baseline levels of key environmental contaminants is the linchpin for undercutting the presumptions on which the industry relies to avoid liability. And that's what the methane area baselines do. So from here, we'll go to a presentation by Bob Ackley, who's the president of Gas Safety, Inc., and then followed by that will be a second presentation by Bryce Payne, who writes the reports for gas safety, the other important aspect. And then later, there will be a chance for questions, and we do have copies of the report that you will be able to get. Thank you.
Thank you all for coming, and it's really great to be out here. I am from Massachusetts. I came out here a few years ago to see what was going on out here. I'll tell you a little bit about what I've been doing for the last 35 years that brought me to this point, to come out here to this beautiful area that I'd never been to. I've just really amazing to me that you live in such a beautiful area out here. That I had never been to, and I've been up and down every street in your town of Delaware and some other towns. It's just really stunning for people who have never been here, and I can see why there's a lot of people that have moved here. I'm a gas guy. I worked for natural gas distribution companies for about 25 years, doing government compliance. And about 2003 came in operator qualification, where we had to qualify all the guys and women, men and women that were out doing any type of gas work, had to get operator qualified. It was always in-house training, and I did leak detection and some mark-out work. But Gas Safety Inc.'s operator qualified to respond to public odor complaints and to perform required leak surveys of natural gas distribution systems and classify the leaks detected to determine the leak repair schedules. So I would go to a city like Boston or Worcester or Providence, or I worked a lot in New Jersey, Connecticut, New York, doing various systems. I worked for a bunch of gas companies, just detecting leaks. And it's kind of funny, one of the ways, we have all kinds of equipment to detect gas leaks, but one of the ways that we detect gas leaks is through vegetation and observing abnormalities in vegetation, mostly trees and grass and shrubs. So if there's a gas leak around, it will kill the trees, kill grass, and kill shrubs. And that's the way they found gas leaks before instrumentation. And I was trained on that my first day of work back in, 1979. I was out with an arborist who started a gas leak survey company, and I did gas leak surveys for many years. So we still do that now. So that's where I came in. I left the gas industry about 8 years ago. And that's one of the things I work on now is damage to public shade trees and other vegetation. I work with cities and towns to identify damage to trees. And it's been a long process. We've documented millions of dollars worth of damage. I'm very interested to see what holds the future for fracking areas where there are gas seeps and what it will do to the vegetation. We have discovered a large seep out in Leroy. I've discovered a few other seeps. They may be natural. I don't believe so. I believe that they're from drilling. But it'd be interesting to see what happens to the vegetation, because there's a microbial bacteria, a methanotroph, that comes in and consumes the oxygen below the ground. And that's what's killing trees that we found out, and it's also very dry. This is just a quick example. I know this isn't what we're here for, but we have two trees here, one with gas at it you can see is slowly dying, and the other one behind it, planted same time healthy, from a gas distribution leak. So we also do research. I've done a lot of work. In my tree work, I collided with this guy from Boston University, Nathan Phillips, and who was associated with Rob Jackson, who's done a lot of work out here and around the country with water. And through Nathan Phillips, we collided with another gentleman from Picaro, who had these instruments that detect methane in parts per billion that they were putting in airplanes and detecting methane on a global scale with researchers. So what we did was we put the analyzer together with a GPS and put it in a car, and we could take data points literally every second and match it with a GPS coordinate. So with Rob Jackson and Nathan Phillips, we did Boston, Massachusetts, and identified all the gas leaks in Boston, which we could already detect with regular equipment, the everyday equipment, but this put it in a graphic form here. As you can see, this is Washington, D.C. We detected around 6,000 leaks in Washington, D.C., and each one of the yellow points represents a leak. And some of the points are higher than others, and that is because we're very close to the source. It doesn't mean one leak is bigger than another. It just means that you're closer to the source, because if you can imagine a street the size of this room, the width of this room, if I drove down one side of the street and the main leak was on the opposite side, I would get a small reading. If I drove right over the source point, I would get a much higher reading. And this will play out in the work that we're doing here as well. When we're close to the source point, we get a high peak, or what I call elevated methane level, and when we're not close to it, we'll get a small deviation. The red shows the path that we took. So I drove up and down every street in Washington, D.C., and Boston, and a number of other cities. We've just done a city in Ohio, and we've done another city in New York. Those papers, they were published on Boston and Washington, D.C., and we'll have a few more published papers on the other cities, but those aren't complete yet. So fracturing, what we did was, in the interim of what I'm doing with trees and research with Phillips and Jackson, I collided with my associate Bryce Payne. I came out here and I said, I want to see what this Picaro analyzer, this super duper analyzer that picks up methane in parts per billion, can do out here, because I think I can do some good out here. I want to see what's happening out here in Pennsylvania and New York with fugitive methane. I really didn't know what I was going to find, but I said, this is something that's really intriguing me. Let's go see what happens. So we pioneered the process of data collection to determine methane baseline levels for any given community location. That was in collaboration with Bryce. Other folks that I was working with had full plates, and I really wanted to see what was going on out here. So what's a methane baseline? It's a collection of methane data that enables specification of a normal range of methane levels for any given location in the methane baseline data set. And we could do a methane baseline for the room by going around and taking points, or we could do a street or a town, or we can do a whole community, we can do a county, we can do a whole entire country. It's just a matter of how much effort you want to put into it. So how's the data collected? We utilize this cavity ring down spectrometer, and there's a couple of manufacturers out there. Picaro's not the only game in town. There's Lycor and Los Gatos and a bunch of other companies that are now doing this. It has the capability to detect methane levels in parts per billion. I mean, this is a tiny, tiny, tiny amount of gas. And we match those readings with global positioning GPS coordinates. So massive amounts of data points are produced and then plotted on geographical information system, GIS, such as Google Earth. You can use any GIS system. So the data is processed. The data is collected and aggregated to determine methane levels. Elevated methane levels are identified, and sources of EMLs are identified. This has been the most difficult part out here because of lack of access to property. So here's the town of Delaware. I mean, you guys all know this place, town of Delaware, New York. I drove up and down every street in town with my analyzer, taking GPS coordinates all through Callicoon, Hortonville, Canosa Lake, Jeffersonville. Really fantastic. I love doing this because I get to see places that you guys have probably never seen, and you live here. Same thing with Washington, D.C. I went down streets that nobody's ever been on, and they've lived there all their lives. So we can put this onto Google Earth, so I'm going to pop this off and take you to Google Earth so you can kind of see what Delaware looks like in some other places. Okay, so that's kind of the same screen. That was a screenshot of this, and you can see the path, and I put the roads in. But Google Earth is really, really neat. We can change the elevation, so you're looking at it from an angle, and we can zoom right in on an area, and you can see the changes in methane levels. See, like here's a spot right here that has an elevated methane level. And the way these are done in the KML, that's just a minor deviation in the methane level. It's magnified 100-fold so that you can see it. If we had 2.11 parts per million and it changed to 2.2 parts per million, you wouldn't be able to see it in the graph unless it's magnified. So the software magnifies the readings so that you're able to identify where they are without going in with the magnifying glass. It gives it to you magnified already. So we have not identified all the methane source points here because of access to property, but we took notes as we went around and identified cattle sources or a swamp or some area where we knew that there's naturally occurring methane. What would be really nice is, like I do with gas distribution systems, I've used this, and then we go out with other equipment and we can pinpoint the source of where the methane is. And this is really what needs to be done here. Here's Lux Road. There was a methane read right here. Yeah, I remember that now. That's where you live. So, you know, there may be some cattle there. There may be, you know, there's a couple of farms in town left. I'm amazed at how much, you know, area there is not that lays fallow. But you can see the elevations at various areas. And some may be alarmed by that, but this is normal to have some methane pockets. They're going to be everywhere. There's no pipelines here that we know of. There may be some transmission lines that go through town. But by and large, you have this wherever you go. Wherever there's livestock, wherever there's a swamp, wherever there's an old dump, methane will come out, and this is just a fact of life. We have some other towns here. We've done Damascus. I think that'll load up here, so we can just kind of zoom over here like that. And we've done Sanford, and Sanford we had one interesting real point up here where we had a very highly elevated methane detection, and it was up on the north end of town. We had a 30 ppm read. And what happened was, I was up by a swamp, and I went through a puddle, and on a dirt road, a dead-end dirt road that hadn't been gone over for maybe a month, and we disturbed some methane. And we know this because when I researched with Jackson and Phillips, we actually go to puddles and swamps and disturb the bottom of the swamp. We go down a foot or so, and we put a chamber on top of the water, and a little bit of methane comes up. And we've captured that methane, and we do an isotopic analysis on it. Now, we haven't done isotopic analysis on here because we haven't been able to capture, but there is the technology to take samples, if we can get them, and run them through an isotopic analyzer to determine source, whether biogenic or thermogenic. Biogenic would be swamp-type gas. Thermogenic would be deep gas, and we can determine that if we get a sample. So we've also done a few other areas. Let's see if I can click these off. The one that was, you know, Barbara spoke of was Wyalusing area. There's a number of towns out there in this area, and the more we put on, the slower Google Earth goes, so I can click these other ones off. There's Delaware, and there's Damascus, and there's Sanford. And we get out to this area here, and you see that one that goes to the moon. We were very close to a source point there. This was out in Leroy, and you can zoom right in on the location, and you can see a highly elevated area over here up to a home up here, and there was methane coming out of the ground all over the area here. And you can see it's a very wide indication, and there was gas coming out of the ground at that location. The other thing we see in Wyalusing area, and I'm not sure all the town names, I know it's a very large area, but you can see it's pretty stable as you come across, but then we'll get to an area where there's a lot of bumps. Bear with me 1 second here, and I'll see if I can get them. Down in this area here, you can see the changes here in the methane. And the other area we have is the Dimick area, and that also had what looks similar, but when you really analyze the data, we come up with a different picture. And the single spike that you noticed up in Sanford is much different than a much broader indication that you may have in the town of Dimick. It's a little. This here is Mashopin Creek Road, and I believe this is Carter Road in this area here. And they've had a lot of problems down there, and I believe that the gas is coming possibly out of Mashopin Creek or on either side of the Ely property, which we know is contaminated. They had a lot of problems there. So this data gives you a picture visually of what's going on, and you can look at it, and it's kind of neat to look at, but it doesn't give you the data. The data is what's important. So let's kick out of this and go back to the data. So here we come to the Delaware statistical data. This is where the rubber hits the road, really. The minimum reading we had throughout the town was 1.72 parts per million. Global background is somewhere around 1.85. Right in this room, if we put the analyzer on, it would be around 1.85 parts per million. You go into your house, I go into New York City or Boston, or at my home, we have a methane level naturally occurring everywhere. The maximum read in the entire town was 4.83 parts per million. And the mean or average was 1.8 parts per million, which is relatively low. That's a low average across the town. You would expect to have some elevated methane levels just by naturally occurring areas. Okay, Sanford. Sanford statistical data. The minimum read was 1.65, even lower. The maximum 30.03, and I identified the source, which was kind of crazy. You don't really think that that's going to happen, but I identified the source, and we had a 30 ppm read. And the mean or average 1.76, so you can see just a little bit lower in Sanford. Now we go to the Dimick area. We had a minimum read of 1.8, which is a bit higher, and a maximum read of 20.49, and a mean or average of 2.20. So that's across the entire town, and I don't believe a 20.49 was anywhere near the source point. That's the big difference, is where is the methane coming from? And then Wyalusing area, we had a minimum of 1.75, a maximum of 7.14, and a mean of 1.85, which is a bit higher than some of the other areas. Damascus statistical data, minimum 1.7, the maximum 6.86, and the mean 1.80. So you get a look at what we call a pristine area. The following is a graph of a baseline data from about a 10-mile stretch of the Southern Tier Expressway, about 5 miles northeast of Sayre, about 2.5 miles west of Owego, New York. And you can see it's right around the 1.8 level, 1.7, 1.8, the minimum, the mean, the maximum, with no, you're on a highway, there's not going to be a lot of stuff around there that you're going to hit, so it's pretty stable. And this is the real picture here that I see is the average methane levels in 6 shale areas, 4 drilled and 2 undrilled. You have the pristine area, which is a little higher on the complete average. The Sanford, New York was a little bit lower. Delaware just below 1.8, in line with Damascus. The Wyalusing area elevated above the 1.8, and the Dimmock area way up to 2.2. Now, there could be reasons why these 2 drilled areas, there's going to be a number of reasons, but we may have been closer to source points. It could have been more broad in Wyalusing. We know this contamination there. We know there's spikes. The key here is to identify the source points. And that we have the technology to do that. We haven't had the access. So elevated methane levels can be easily identified. I've been doing this for 35 years with gas distribution systems, and I don't see any difference with this type of activity. The equipment's much more expensive, but it's the same process. We go out and we grid off an area, we can find the source point. The data illustrates differences between drilled and undrilled areas. Elevated methane levels above an established baseline should be investigated to determine their source. Now, the baselines will change day to day, season to season a little bit, but elevated methane levels will be above that baseline. So you can identify the location. We could sit down at any point with an elevated methane level, take out an anemometer, have our equipment there and say, okay, which way is it coming, north, south, east, or west, and just keep going till we find the source. It's not that difficult. So technology is readily available to pinpoint sources of elevated methane emissions. The access to property is critical to pinpoint elevated methane levels. When I did gas work for any gas company, I was an agent of the gas company. Anybody that has gas at their house, a pipeline, they signed in their contract that anybody from the gas company could come on their property at any time. So people would see me in a safety vest walking onto their property. Hey, what the heck are you doing up on my property? I said, well, I got to test your pipes. They said, well, who said you could do that? I said, well, you signed it in your contract that we could do this. Oh, okay. We don't have that here. That would be really great if we could have that as a standard out here, that if you have an elevated methane level, because if you consider yourself in a butter and there's somebody wafting methane over your property, you should have the right to find out where that source is coming from, because you're getting trespassed by property. The methane is actually property. So methane baseline should be required of all locations before natural gas extraction commences, and on a periodic basis during and after extraction concludes. Now, we haven't come up with an exact protocol for that, but I would say, obviously, before you do any of this mining, but then at periodic intervals as mining commences, and then as it subsides as well, to see what's going on and whether you're going to have a problem, because this stuff is odorless, it's tasteless, it's colorless. You can't see it unless you have the equipment that I have. Then you can see it. You can see it right up there on Google Earth. And I'm very proud of this work. I'm excited that you folks have come out to look at it. I think everybody should have access to this technology, this information, so that you can make decisions. Whether you're for fracking, against fracking, doesn't matter to me. This is information about your property, your town, your community, and what's going on. And I think that that should be important. It doesn't matter what side you're on. If you are going to do this methane mining in your community, you should know what's going on within your community. So thank you very much.
Bob's already given you some stuff going into about methane and Barbara too. I just call this why worry about methane and how. How do we worry? How are we going to concern ourselves with it? What are we going to do about that? So anyway, methane is a natural product. It's a part and product of life on Earth. It's always present in the groundwater and the air and the soil to some extent or another. In most cases, though, the levels are low. There are places on Earth, I'm sure you've all heard of perpetual flames. There are natural perpetual flames on Earth. Some that have been burning for thousands of years, where natural gas naturally rises and comes up these seeps, and then at one point or another just gets ignited for whatever reason and keeps burning for thousands of years, literally. In those places, there is a natural connection between a deep natural gas deposit and the surface. That's very interesting on the one hand because it means that, hey, natural gas does come to the surface sometime, which you can interpret either way. That is to say, well, we shouldn't worry about this natural gas coming to the surface when we do fracking because there's natural gas coming to the surface anyway in these natural locations. The flip side of that is to say, well, wait a minute, if there are pathways that will bring natural gas to the surface under natural conditions, what happens if we connect a new gas source, like fracked shale, to one of those pathways that didn't previously have gas connected to it, which results in geological seepage or geological leakage, and we'll get to that in a bit. Anyway, methane is a direct hazard. A 5 to 15% mixture of methane in air is explosive, dangerously so. And above 15% methane is asphyxiating. I'm sure at some point or another you've either had experience with or you have read about people who have died, for example, in septic tanks. They'll go into septic tanks to clean them out and they suffocate because that septic tank is full of methane and they don't flush them before they go into them. And that's a consequence of methane. It's not that the gas in there is poisonous. It's because methane is not directly poisonous, but it will suffocate you if the concentration is high enough. Methane is also indirectly hazardous, which is more what we're concerned about here today. It's indirectly hazardous, and I'm going to do this backwards. I'm going to say because there are socioeconomic impacts related to when you get enough of it and it starts impacting groundwater and air, you're going to have dislocations. People are going to have to leave. You're going to have economic impacts for the families whose lives are being disrupted. Even if they can stay there, their lives are going to be changed. Methane is a potent greenhouse gas. And I'll let that stand for the moment. And then there are effects on groundwater quality. For whatever reason, these have been largely ignored. There are some studies that have been published recently, and there will be more coming out. But it stands to reason it stands to reason for folks like me who worry about this sort of thing, who think about it. If we take groundwater, and groundwater is actually really interesting stuff because it flows through the ground, it trickles through rock and natural formations, and it's in what we call a chemical equilibrium. The chemicals in the water are at an equilibrium with the chemicals in that rock. And so, typically the thousands of years of that equilibrium has been there to establish itself. Now, what happens if you introduce some methane into that system? And the methane itself doesn't do anything directly, but it does stimulate microorganisms to grow. And it also, if it's present in large enough quantities, can simply displace other gases, like the air that would be naturally in that, whatever that air might be down there. And if you displace that air, and you cause microorganisms to grow, you change the oxygen status of that groundwater. And if you change the oxygen status of that groundwater, that changes the chemical equilibrium. That chemical equilibrium is driven by that oxygen status. So things like selenium and arsenic and radium, these elements become, they may increase in solubility, they may decrease in solubility, depending on the change. But in most cases, one or more of them is going to change in a direction that you don't want. So there are effects on groundwater quality that are foreseeable from the chemistry. We know them from other experiences with landfill gas and other kind of hydrocarbons getting into groundwater. But in terms of fracking impacts on groundwater, it hasn't been addressed yet. Outside of one, and I understand a soon to be released another study out of the University of Texas for shale gas in Texas. And they are seeing increases in arsenic and selenium levels associated with those contaminated wells. Okay, so where does methane come from? We have what we call biogenic gas, which means just it's generated by biological processes. The ones that, and Bob mentioned some of these, we have swamps and sediments and rivers, we have sewage systems, we have animal digestive systems, and I'm talking about animal gut, cattle, and so forth. And human beings, too. About 30% of human beings produce methane in their gut. And we have thermogenic gas, which comes from geological sources. It's called thermogenic because it's produced by heat and pressure underground. And thermogenic gas is associated with deep deposits, coal, oil, gas deposits. It is released naturally through natural seeps and volcanic activity, and it's also released by the fossil fuel industry. When they drill down and contact that stuff, that gas comes out. It has a pathway out. It may be through the mine shaft, it may be through a well shaft, it may be through leaks once the material is brought to the surface. Now, the interesting thing about natural processes is that there are a lot of them, and they all tend to balance each other out. In the case of methane, there's a dynamic balance between natural methane releases and natural methane decomposition processes. And that results in a balance that's maintained for thousands of years and longer, where methane levels remain stable and relatively low because nature is producing methane and decomposing methane. Now, what comes up, what we do, and this is with or without fracking. Human beings interfere with natural methane balance. We increase the release rates and we decrease the natural decomposition rates. And we do that by things like agricultural activity. We grow rice in rice paddies. We raise a lot of cattle. Both of those rice paddies are effectively swamps, at least for part of the year. And they release significant amounts of methane. Cattle, of course, everybody's heard about that. We produce waste, sewage, municipal waste, and we put that in landfills. And landfills release substantial amounts of methane. And we produce fossil fuels, and we use them. And in the production, the distribution, and the utilization, we release methane. Now, what we also do is we degrade natural systems that would otherwise be scrubbing methane back out of the atmosphere and out of the soil. Our agricultural practices interfere with normal soil microbiology. That normal soil microbiology is important to reducing methane levels. And we also pollute the soils and the groundwater. We add things to soils and water that inhibits or changes the balance of the microbial community that's in those systems. And when you change that balance of that community, you diminish their ability to consume methane. Okay, so Marcellus natural gas, methane, and you, or all of us for that matter. Methane constitutes about 80 to 99% of raw natural gas. There are some natural gases that can go a little lower than that in terms of methane composition, but that's a typical good number. And about 93% of commercial gas, most U.S. commercial gas is set at around 93% methane. It has also ethane and propane and a couple other gases in it. But in the Marcellus gas is what's called a dry gas. Most of the heavier hydrocarbons, the ethane, propane, and so forth, have been processed out naturally over the years. Most of the organic material that was converted to methane got converted even further because it's fairly old material, And so a whole lot of it was converted to methane, and so we get what's called dry gas out, which means it's typically greater than 95% methane and sometimes 98, 99%. And natural gas production is always associated with increased releases of methane. The question is not if, but how much, where, and when, and with what effects those releases occur. So we have two primary environmental and health concerns. Methane is a potent greenhouse gas. It impacts on the climate change issue and heavily. And it is a groundwater contaminant with direct and indirect hazards that I discussed before. And in terms of fracking, most of the time the direct hazards you're concerned about when you have a well blowout, and there have been some. If one of those things ignites, it's a extremely hazardous situation. The other kind of situation that can happen is this is not a large release, but if you can get a high level of contamination in groundwater, that groundwater can carry that methane into closed spaces. So if you have a pump house on your well that's not ventilated, and the water is carrying gas up into that pump house, that gas can accumulate in the pump house, and at some point you can turn on a light switch, or your pump switch goes on and ignites the gas in that pump house. And there was a fairly serious explosion here, and I can't remember, Barbara knows where it is, where they had a situation like that. Fortunately, no one was home at the time, and the explosion didn't do anything but destroy the area around the well. But it does happen. Even more concerning than that is some people's wells are connected with an underground. Most people's wells, our pump house is connected to their house by a pipe, and that pipe is usually in a bed of stone. And that stone is a porous pathway. So if the pump house gets loaded with gas, that gas can start moving through that bed of stone and can move into your basement or wherever you connect with your house. So this is not a trivial matter. This stuff can get in if you have heavy contamination of water, you can have this problem. Now, the other one is sometimes you don't have heavy contamination of water, the groundwater. You have moderate contamination or light contamination. And then we get back to that question again, well, what's that going to do to the water's chemistry over the long term? And in all likelihood, you're going to see changes in things like arsenic, radium, sodium, these toxic elements that are impacted by the oxygen status of the water. So what does all this have to do with methane baseline data? The gas industry is exempt from most environmental laws, one way or the other. And as a consequence of that, landowners' only protection against industry errors or misbehavior is to demonstrate damage or injury, to be able to show that you were damaged or injured in the event of a contamination. It's not that you need your pump house to blow up. We don't want that to happen. We want you to be able to establish that you have problems before you reach that point. And so in order to do that, you need to have some reference. Such a demonstration almost always requires the ability to show that what conditions were before damage was done and where the contaminants came from. So that's really the idea originally behind a baseline. I had, in my original research work, I had a slightly different orientation, which was to look at the question of geological leakage of methane associated with hydraulically fracked ground. But we end up doing the same thing. Looking at a methane baseline and looking at that research question is done the same way. Why a methane baseline in particular? I mean, why methane and not something else? Because contaminant methane presents acute and chronic risks. Marcellus gas is typically more than 95% methane. And methane is the lowest density component of natural gas, which means it moves very quickly. If the contamination is here, it's going to move over the hill, it's going to move through your water, it's going to move up through the ground very quickly, much more quickly than any other contaminant. It can also be released through poor gas infrastructure and through altered geological pathways. And by that, what we mean is there's a system of fractures always present underground in the rock and the geology in your area. And if all of that material, those fractures have always been exposed to water and air. But if you go down below that and you fracture the shale that had previously been containing gas, and you fracture that shale and release that gas is now looking for any pathway it can find. And if during that fracturing process you connect those new artificial fractures with the old pre-existing natural fractures, you're going to have pathways that the gas will move through, and it will move to other places besides the wellhead. And this is where what Bob was talking about comes in terms of the instrument. We now have practical, rapid, reliable, and accurate methods for doing field measurements of methane. Field measurements of methane not too long ago were extremely difficult. You had to go to the field, you had to pull a sample, and you had to actually take the sample back to the lab and put it in an instrument to measure it in the lab. These new cavity ring-down spectrometers actually run in the field, produce very hot, reliable data, and they run very quickly. Okay, so Bob's already been kind of over this, and I don't want to spend too much time on it again. And just very quickly, the spectrometer that we've been using generates one measurement every about 3 to 5 times a second. So we get 3 to 5 methane measurements and locations per second while we're out in the field running. So let's assume, just to get a picture of this, let's assume we're driving down the highway at 60 miles per hour. We're going to get a measurement every 20 feet or so as we drive down the highway. We don't drive down at those speeds when we're surveying your towns and townships. You drive at local speeds, you drive slower. So we're getting measurements every few feet. And while we're doing that, Bob mentioned that we make field observations of potential sources. We also use Google Earth. Google Earth has some good recent imagery on it, and we can actually zoom down in Google Earth and see what is that place. We can see a methane peak, and we can search the ground around it and say, that's a farm, or that's a pond, or that's a swamp. And so we can do that, through our observations and through Google Earth. We can narrow the field fairly quickly as to what's a likely source in that area without ever actually going there. If we want to pinpoint, that's a different question. Then we have to go in with an instrument and actually do it. But we can make a pretty good guess. We process and analyze data. We survey every publicly accessible roadway. That provides a significant advantage for example, municipal governments, public interest groups. You can go anywhere and you can detect what's going on with the methane without having to intrude on other people's lives or their private properties. If they want to know more, then they can invite us in, they can allow us to come in. But as a community or as a municipal authority or state or any authority, if you want to know what's happening in your jurisdiction, we can tell you without having to intrude on anybody's private property. We process and analyze the data. We cross-reference unusual methane levels, potential sources, and we prepare and submit a report, which is, you can get the Delaware copy today. Okay, what does a methane baseline look like? It's actually just a lot of data. Typically hundreds of thousands of data, of lines of data. And when we collect the data, each one of those lines has about 28 data points on it. We actually end up using for these reports probably about 6 or 7 of those. So, we're processing a couple million data points for each one of these reports. Sometimes more, sometimes a little less, but in that neighborhood. We can look at small subsets of the data. If we really want to see what's happening in a particular location, we can take that data and really zoom in on that particular spot and look at, say, 50 or 100 data points. The trick is you got to know where to zoom into. Not everything is interesting. Well, most of the area doesn't have much methane. So how do we look at that data? How do we work with it? And you've already seen this stuff, but the easiest way to do it is to do it graphically. You can't look at 2 million data points. You just can't do it. It's like looking at a pile of sand. So what do? You have to simplify it or not. Because when you look at it graphically, you don't necessarily need to simplify it. So we're going to go very quickly. Bob's already done some of this. We're going to be looking at data from 7 areas in eastern Marcellus Shale region where we have already run methane baselines or performed methane surveys. There are 4 undrilled areas, 3 drilled areas. In the 3 drilled areas we looked at, we were asked to look at those because there were already contamination problems there. We can tell you from driving in other areas, the picture changes somewhat, but not a lot. There are gas wellheads around which we have not found methane. But that same well, 2,000 feet away, is spewing methane up out of the ground. So that's not to say that happens in every well. We honestly don't know how many wells it happens in and does not in as a percentage of all wells. But we do know that it's happening. Okay, so here are our areas. We have this area here. Bob mentioned, I think, all of these briefly. And the Leroy area over here is where we had a blowout back in May of 2012, which we know that up until at least July of 2013, the last time we were there, that it was still venting large amounts of gas out of the ground, not out of the wellhead. The Dimmock area, Delaware, Damascus, and Sanford, and the Wyalusing area. By the way, these yellow and red colors have no significance. Those are holdovers from when we produce our reports for each one of these areas. The Google Earth image that we use, we don't get to choose the color of it. So what happens is we need those graph lines to be visible. We need you to be able to see them. And sometimes the background has got too much of a reddish tint. We put red on it, you can't see it. Or it's got too much of a yellowish tint. You put yellow on it, you can't see it. So we have to pick and choose red or yellow for each particular case. And to generate this image, we just grab those out of all those reports and put them on. And so you're seeing red in some, yellow in the others, but it doesn't mean anything in terms of high or low or good or bad or anything else. Okay, so Bob already went over this with you. He did it as a graph, and I'm putting it in here as a table. This is the pristine area. And and I just want you to see those numbers right quick. Those are the actual numbers. Minimum was 1.769, average 1.781, and the maximum was 1.793. Now, these are all at or below what we would consider to be the atmospheric average for North America. Methane, that's a methane level that if you went up in the air a couple thousand feet and flew your plane around, that's about what you would see. So this pristine area is important for two reasons. One, it shows us what methane levels can look like in the real world, on the ground, because we run on the ground. We're not flying this thing in plane. We can, but we're not. And so the importance of that is you need a reference point. You need some idea to get what can it look like. In this pristine area, you see 1.7, 1.79 is what it can look like, and it's very stable. And that's important because what that shows us right here is the 0.024. Between our minimum and our maximum, we varied by only 0.024 ppm. That's a very small amount. And it's just for you to have an idea of two things. That tells you if we take the natural variation and add on the instrument variation, because the instrument will drift a little over time, not much, but it does a little bit. Even under those conditions, we can still, over a period of several minutes and 10 miles, we can, several minutes or more, I'm not sure what speed Bob was arriving at that point, the instrument and the natural system is that stable. So that gives us an idea of, well, because a lot of times you see these variations, and you will see them in the baseline data. We're going to show them to you. Does that variation matter? Is that little variation, does it count? The point of this is 0.024 is very low. And it's important to understand that to begin with. Okay, so Bob's already shown you this. This is a town of Delaware. They're just illustrating where these elevated methane levels were. The minimum was 1.715. Now, what I wanted to show you on this is this particular slide. Bob explained to you we use an exaggeration, a magnifier on these things. And we do it mathematically. We tell Google Earth through a program how much we want it to exaggerate vertically the methane levels. In this particular case, the magnification factor was 1,000. What we do is we take the difference, and you can see why. I mean, if you have a difference between 1.86, as 95% of the data was below 1.86, and the minimum was 1.715. So we have 0.15 ppm. We have to multiply that by a really big number to get it to show up on a map that big. So in this case, we were using a multiplier of 1,000, and we deducted 1.85 before we multiplied by 1,000. Now, what that means is you'll see in here in certain places, like right in here, you see these little places where there are little gaps in the data. And that's because at that point, the methane level was below 1.85. So when we subtracted 1.85, we got 0 or a negative number. When you multiply by 1,000, it doesn't show up. All of those roads were continuously surveyed, but that's the reason you don't see them here. The reason I did that was 1.85 is an accepted normal minimum standard. And it shows how most of Delaware is relatively pristine in terms of methane levels. You don't really have much. There's an area down here that has a bit more, and this side here and this corner up here. But these are either associated with, and I'm going to say either. I went over all of them. I looked at all the peaks. I looked at what was around them, and they're all associated with residences or ponds, or in one case, what looked like an old sawmill, or farms. So all of your sources here you see are natural. But even more, I guess, comforting, if you will, I think that 4.83 was the old sawmill location, as I recall. Anyway, the point is we multiplied by 1,000 to get those peaks to that point. You don't have much methane in Delaware. There just isn't much here. Okay, this is Damascus. Everything I said on the previous one applies here as well. Damascus, interestingly, Damascus methane levels appear to be higher than a typical situation. But you have to kind of remember on this that we ran, well, you didn't know, but I'll tell you now. We ran Damascus on 5 different dates. And there's seasonal variation. Winter shows the highest methane levels. They're not hugely higher, but they're higher. And then when we generated overall methane data for Damascus, we averaged all 5 of those dates. And the consequence of that is that winter level pulls up all the other 4 because it's higher than the other 4, so it makes the methane levels in Damascus, on average, look somewhat higher. Most of Damascus Township looks most like most of what the town of Delaware looks like. Most of it is quite low. And all of the peaks that you can see, there are some, you can see in here, again, a multiplier in this case I think was 500. But you can see there are some peaks in here. But again, in every case, when we track back, in some cases we actually did. We went right back there to where that peak was, took the instrument back and inspected the place, and it was always farms. Farms or residences, presumably the septic system, or a local small water body. By the way, this out here in the background, the red is DIMIC data, and the yellow behind, well, no, that's all, yeah, the yellow behind it is Wyalusing data. Now, the DIMIC data, the multiplier we used on that, the vertical exaggeration, was a factor of 100. It was 10 times lower than what was used here. And you have to factor in here that you're looking at perspective. In other words, that's the Google calculates perspective and pushes that peak back. So the point here is that when you can see that even with a factor of a multiplier that's 10 times smaller and being much farther back, that peak right there is almost the same as this peak right here in Damascus, and that one's, what is it? I don't know, 60 miles west to DIMIC, I think, 40 to 60, something in that range. So anyway, this is the town of Sanford. Now Sanford, an interesting point here, is Sanford was the lowest baseline. Again, it's not dramatically different, but it was the lowest. There's that 30 ppm peak, and we're looking west to east here, by the way. These other peaks are associated with, this is farms, this is a town, I can't remember the name of the town. The largest town in Sanford right there, and we're guessing they either have a sewage system generating methane or maybe they have natural gas service, I don't know. And all of these other ones out here are farms or ponds, or this was a swamp that Bob mentioned. Now, this area down here is really interesting. There are a number of lakes down here, small lakes, creeks, what have you. And we got a number of peaks here. And that one there was particularly noticeable with 6.6 ppm, the highest after the swamp. And the interesting thing about that is there is one sort of, I don't know what you want to call it, wayward soul, shale gas well in far northeast Pennsylvania that happens to sit right over here. It may be nothing but a coincidence, but it was really interesting to see that we got this area of peaks here with the only shale gas well in the vicinity right across the line in Pennsylvania. I think it's 1/3 mile on the other side of the state line. Okay, so this is the Wyalusing area. Barbara showed you this early on the poster she had up here. Just wanted to show you what does the baseline look like. This is what we call a monitoring survey. We can't baseline Wyalusing anymore. Wyalusing is contaminated. We don't know what it was before. We can make a good guess, but we can make a good estimate, but we don't know. We didn't measure it before. But what we have here we ran the survey on this area because we were asked to do so because of a contaminated area. These two things you see here, the orange one is a DEP designated methane migration impact area. I believe that was called the Sugar Run impact area. And this one over here is another one in blue, called the Paradise Road impact area. Paradise Road is where that settlement occurred. The three families came to a settlement. And the settlement basically was the gas company said, we'll buy your properties, you leave, go away, and that's the end of that. Now, these were the subject of DEP consent orders that Chesapeake, I believe it was, in the consent orders that was were to do a number of monitoring and well construction correction and so forth and so on things. We did not know at the time we went out to make that survey that those impact areas were in effect. I think they were imposed in 2011. And we collected this data in late 2012 or early 2013. I can't remember right now. Anyway, the point is this impact area and this impact area, you can see that they overlap here. And you can see when we did the survey, where's all the methane? It's two spots, here and here. The only reason they're separated is because there wasn't a public road in between. We could have gotten in between and we probably would have found it there too. The point of all this is we have known contaminated areas that were contaminated at least a year before we got there and presumably being addressed as required by DEP. And we picked them up. And then there was DEMIC. Of course, everybody's aware of DEMIC, and I'm not going to delay on this because I'm getting prompted to move on. The point of it is that I'm going to show you two things about the DEMIC area very quickly. This one is to just show you, this is what I mentioned, this is the highest peak, one of the highest, I shouldn't say the highest. This is one of the highest peaks we encountered in Damascus Township. And I chose it because it has a shape reasonably similar to this peak in DEMIC. But what I did is I took that other image and I put it on this image and I scaled them so they're scaled the same way. And when you scale them the same way, this one here is about 3.5 ppm. And it lasted for 0.06 miles. In other words, from the time we detected it as a peak to the time it was over was 0.06 miles. In DEMIC, this peak was about 15.4 ppm at the top, but it trailed out well above the local baseline. There's about 1.9 in both areas. It trailed out for 2.9 miles before the effect of that elevated methane level diminished back down to normal levels. Now, this is another way to give you an idea of the same thing. That's the Leroy blowout out there in the background. We're coming into, I'm going to drive you through a series of slides. We're coming in from the north through Montrose into DEMIC. And I just want you to watch the red, because the red here is the methane level. So you get an idea here. This area has been drilled, but not heavily. And so as we drive on through this, we go on, there's that little red dot, South Montrose, and then we start moving into the DEMIC area, and then we move farther into the DEMIC area, and I actually pulled back on this one so the whole thing wouldn't blot out red. And so the point being here, this is what it's like outside the DEMIC area. As you drive in, that's what it's like. So, main thing, document current conditions. Baselines do that. Second thing, You can detect and determine when contamination is going on when you can't even get access to the property. If you think it's happening, we can find it, and we can find it without going there. To pinpoint, we need to get on, but to tell you it's over there, we can do that without getting on the property. And then there are other things that we can do with these baselines on a broader scale. And what will actually happen is we're going to take a break for questions and what have you, and then I hope that some of you have time, and I'm going to do another bit after we get done with questions and a break. So I guess that's it. Thank you.
I just want to know, by the way, Bryce is a PhD soil scientist, and he's been working as an environmental scientist since 1992. And at the town of Delaware was the first one done, even before town of Sanford. And this is the first public meeting about this information that's ever happened. So I just wanted you to know that. Secondly, that this is the report on the town of Delaware, which will be available as you leave, which you can take with you. It will be put online, but you can take one with you. And also for anyone interested, we have a few copies of Bryce's slideshow, and also after the Q&A, if anyone's interested in delving further into how he analyzes the data and the specifics of the analysis of the data and so forth, he would like to go into that with anyone interested. So Trish, you're going to say a word or two more, and then we'll line up in the middle for questions.
I also just wanted to mention, I'm here to do the pitch, but we're really in need of funds to pay for this report. It costs around $8,000 or $9,000 to do this in-depth report in each of these towns. And unfortunately, we only raised just shy of $2,000 for the town of Delaware. While I'm so grateful to all of you for any contributions you've already made, if you haven't, or you may be able to make one in the near future, you can do so via PayPal on the DCS website, or send in a check or a cash donation. It would be so wonderful to do that. So can't thank you enough. And obviously, it's very clear the value in having something like this. I'm sure you can agree with that, but it has to get funded. So we really appreciate it. And we're going to start the Q&A. So if anyone has a question, if you'd please come up to the microphone so everyone can hear you. We are taping this so that so you'll know you'll be being filmed and your question will be recorded.
So we're in Damascus on the Delaware River between Callicoon and Coshecton. And we got our water tested nicely by who DCS recommended, and we had beautiful water quality for our well. And just like a quarter of a mile south of us, all of us got our water tested. They tested the water, and there seemed to be a ton of methane in it. It flamed up. So one of my questions would be, is that because their well had methane in it and right near us it didn't? And then just to add is, what's the relationship between natural gas and methane? Because it seems like 95% is methane. I mean, I'm embarrassed by that question, but...
That's okay. Can I just ask you to stay at the microphone for a moment, please?
Sure.
And just, if you could rephrase, whose water had a high level of methane in it? Your neighbor?
Our neighbors right next door, and I think they knew there was problems with their water. I mean, when the woman tested it, they kind of light a match to wherever the water comes out or something.
Okay.
And she said there was a lot of methane in that.
But your water test came back very good.
Our water, came back great. The third thing would be, let me just say, is it sounds like it would be important to be able to have someone else's land surveyed if there's a suspicion that it could be injurious to the community or to your house. Is that something you could get townships to pass as an ordinance? Anyway.
Okay, a couple of things. First of all, there are no dumb questions. Second of all, These surveys are being done now on public roads because you don't need permissions.
Okay.
They can just be done. Anyone you can get a permission for is fine. We are actually working on a proposed municipal ordinance that could be passed in any town that would require all areas to be surveyed for a number of things, including an area methane baseline. And if you write to me at the DCS website, I do have the preliminary layout from our attorney of that municipal ordinance.
Great.
But as things stand now, you need permission for property access.
Great.
Now, as far as the other question about where does methane lie and how does it get there, you're dealing with both the biogenic and the thermogenic methane. One is more surface and one is deeper, but let me turn it over to you guys.
You do get that's why I mentioned early on get closer. There are natural occurrences of high levels of methane in groundwater or just as seeps. They're just coming up out of the ground.
Right.
That does occur. Okay. Now, in this particular situation, I mean, what immediately came to my head is give me your address and so I can see where you are and your neighbor is.
Okay.
And we'll see if we picked up methane levels over there when we were running the survey. Okay. Now, I don't know what time frame these tests were done in, but we do know when our surveys were done.
Okay.
The other thing is that there have been cases like the one you're talking about. And they have typically any one of several explanations. One that I've seen in the past is that somebody was actually tapping into water that was running through an old septic tank, an old septic field. Typically, those things will exhaust themselves after a while. So if that went on for years, or even or even 1 year, then you would wonder about that. That's an awful long time for an old abandoned tank to run. You can have natural sources. There can be natural deposits of biological material down there that are decomposing and generating methane. In Pennsylvania, it's very common to have that effect from coal deposits. Coal veins release methane. And you can have natural gas seeps. They do happen. So in your case, would be, like I said, be particularly interesting to us is an address so we can check it, so we want to see what our aerial survey showed, our air methane survey showed. And then the kind of thing you're talking about, you can investigate it. You can determine what that's coming from. It can be investigated and determined, is it biogenic, it's from a biological source? Is it thermogenic? If it's thermogenic, you can look at it to see if it's related to some known local gas, the reference that somebody might have available. Those things can be done. It probably would be advisable for them to look into it. If they can light their water on fire, there's an issue.
Okay. Great. Thank you.
The other thing is that if you are in good terms with your neighbor, you can ask them. There can be isotopic analysis to find out exactly where it's from and what the qualities are of it.
I wanted to find out what constitutes access to property. Does one physically have to, I haven't seen the machinery, the actual measuring device that you have, but does that have to be set near or very, very close to the ground to be able to gain readings? Or can you have it way high up? I mean, how high up are you? You're in a truck, so it's up like what, 10 feet or 5 feet? Or you have it in the air? Because the reason why I'm asking this is because I'm wondering why it isn't possible to take a helicopter. You are physically not on their what constitutes access? Do you have to be walking on the property, or can you in fact be in the air, a low grade of height for a helicopter to be flying over? And also, I have another question about access. There are some wells that are non-producing wells, and in fact, the industry could use those wells as answers to the fact that there's no methane coming up from the earth because this well here is not producing any methane. In fact, they haven't drilled down far enough into the shale deposit to access any methane, and so they could be using that particular well as their exemplary example for why they don't have any methane problems, But anyway, back to the access issue, I'm curious about that.
Access is gaining, being able to go on the property. Last time I rented a helicopter, it was $400 an hour. So if anybody wants to rent the helicopter out and pay me, I'll come over with the equipment, and I can go over anywhere. It's certain height. There's certain height restrictions. I'm not a pilot, but we can put this in the air. It's just the expense.
How high up do you have to? Right. Okay. So then, how high
That's
up
up to the, I'm not a licensed pilot. The pilot would know how high he would have to be off of somebody's property.
No, but how high do you have to be to get the reading?
Well, that's a good question. I would rather have access to the property with the equipment, and I can just use either. I have portable equipment that I can access, or mobile equipment that you can mount in a vehicle. So it's basically getting access, not being trespassing, to get onto property. As far as the helicopter goes, I wouldn't advocate for that.
Well, how about something where, I know this sounds a little crazy, but having a rod up on the, having a rod up on the, I'm actually kind of serious about having a rod coming up and having an extension, kind of like a hydraulic in the air, an extender that would go out quite some distance.
But I just want to interject that it's pretty sufficient from the public roadway, adjoining the property. I mean, if you were on Lux Road, which is my road, and I have, 53 acres parcel, and you're going up and around my parcel, you're going to get a sufficient read from that finding, aren't you? Or you don't actually have to step and cross over the line onto my driveway, right?
The more access, the better.
Let me say something that might help you understand. Your question about how much height do you need doesn't matter. Just think of it this way: if there's methane coming out of that glass right there, we can measure it right here, and we'll pick up a lot of methane. We can measure it here, we'll pick up more. We can measure up there by the ceiling, and we will still get it.
A lot?
We won't see it much.
Won't it dissipate
we'll see
a lot?
it. We'll know it's there.
Yeah.
But
it dissipates
this is going
a
to be. I'm going to try to give you a rough example. It's easy to see cattle 500 feet away. As far as methane is concerned, that's not difficult for us. So the point is that typically Bob runs with this thing mounted on the car, so the air intake is what, about 12 inches off the ground? Yeah. So he drives the vehicle with the sample intake, 12 to 18 inches off the ground, something like that, and just drives the roads. You can put it on top of the car. You can put it on a mast way up in the air. You can extend it out front. All of these things have already been done, so none of those things are a problem. It's just a question of why do them, because we can measure it anyway. The instrument is sensitive enough that you can put it. If you can go up in a helicopter and still measure it, then whatever we want to stick out on a car isn't going to make any difference. The problem in a helicopter is there are other tricks to it, because a helicopter has a horrendous downwash off of the rotor, and a fixed wing airplane is better. I'm working with a research group right now that is trying to find a way to make small drones, to put these things on small drones. Yeah. And so anyway, those things are all being discussed. But as far as access is concerned, if you want to know definitively where it's coming from, we go in with one instrument or another and walk up to it and test it right there. That's the way you do it.
Does the industry collect any data like this that you're aware of? I mean,
not that we're aware of. We're not aware of any. That doesn't mean they're not. It just means that we're not aware of it.
Wouldn't you think there is? Don't they want to monitor methane levels?
Say that again?
Would you think that they would want to monitor methane levels for any number of reasons?
That's a loaded question. No matter
I'm not loaded. I'm just,
No matter, I can answer. There are two ways to answer that. I guess one is being kind of, on the one hand, that they should want to know. Well, yeah, it seems like they should want to know. If for no other reason, they want to know if they're losing product. If they're losing methane, they're losing product. On the other hand, that for a variety of economic reasons I can easily think of, maybe they don't want to know. It's easier to ignore it. So I'm sorry, but your question is loaded. You can take whichever perspective you want.
Right.
So It's a fair question. It's just that however I answer it.
So unless there is a baseline done by somebody, they wouldn't need to do their own, for instance, we're discussing baselines here so we know if there's a change relative to a gas drilling activity.
Right.
So they don't really need to do any baseline so that they could prove that they didn't make any change to their gas drilling.
If they wanted to go that route, they could.
Right. But to your knowledge, they're not.
To my knowledge, they haven't.
Okay, thanks.
Let me just add one thing to that. A key factor in the settlement of a number of lawsuits, like the one I mentioned in Terry Township, that's it's in that picture leaning against the audio stand, was that there were baselines done. And because of that, the industry settled very quickly in what could have been something that was much more highly disputed, but the fact that they had real data, not, I think, just 2 points on it, 2 different wells, so maybe it was only one. I honestly don't remember, but I know they had some baseline data, and that forces them to recognize when they do cause contamination. And this is admissible in court data, although different from the one that was in that lawsuit.
How much does it cost for a thermogenic, biogenic test?
Isotopic. That's how they do it.
To tell whether it's coming from deep underground or whether
a single sample. I'm sorry, a single sample on that. You're talking usually in the range of. I'm doing this by recollection now. I think there are 2 or 3 companies that I remember doing it, and depending on what you ask for, something in the $200 to $700 range, depending on what you ask for. Something like that.
Hi. I have a couple of questions about infrastructure, pipelines and compressor stations. We have one up on Hungry Hill outside of Long Eddy, and I saw where you drove up 97. I don't know if you went up Hungry Hill Road. You did? Okay, because is there a way for us to see that report, or is it written in the report?
We didn't write a report on that. I did survey Hungry Hill Road. I believe we have the data, and it shows clean up there.
It does, and we're near the pipeline.
There was nothing up there
Okay.
when I went up.
Okay.
I don't believe. I think there was a pipeline in, wasn't there?
Oh, yeah, there's been a pipeline.
The pipeline was in. Now they're going to put the compressor in.
The compressor is in.
Yeah, it's clean.
It's in
My
now.
experience is I haven't seen many leaks in the transmission
Okay.
lines.
Oh, okay.
They're under such pressure.
Okay.
So if there's a leak, it's really quite dramatic to have a leak.
The compressor station's built and running right now.
Yeah,
Okay,
I can't comment on what's coming from the compressor.
Okay, maybe I can talk to you about that afterwards.
Sure.
I wanted to ask you about when you're doing your testing, do you have to watch the weather and choose a day that's not like really windy, rainy?
I really like to do in all weather.
Okay.
To see what's going on. The best days on a distribution system for methane detection, believe it or not, are a light rain, overcast, low pressure day.
Keeps it down, okay.
And gas dissipates very quickly in a high pressure atmospheric condition. But that doesn't say that makes a big difference in the traditional equipment I use. The methane analyzers and parts per billion, it's still going to show up. It doesn't really make that much difference. You may have a little bit difference in levels, but because of the magnification, we can see everything. So the equipment's unbelievable.
Mm-hmm. I spoke with someone from Columbia Gas the other day, and they did say they do go up and down the pipelines to test for leaks on a regular basis, but I don't know. They must have a GPS on a four-wheeler or something. I don't know.
Well,
Just to
on the
answer a question
transmission
about-
line?
Supposedly they are testing.
You're talking about the transmission line?
Yeah, the pipeline itself.
Department of Transportation requirements are 4 times per year.
4 times. I think he told me 3. That
Well,
Millennium is doing 3.
It is 4, I believe. It's 4. It was 4 in Massachusetts, and I think that was a federal reg. I believe the federal reg is quarterly patrol of the transmission line. Now, they can do that by air in rural areas, depending on the density of residences and buildings. It all goes on, there's different classes of building density. So if you're in the lowest class building density, you can actually survey by air and observe for abnormal vegetation,
Okay.
for a leak. Or you were looking for washouts, changes in vegetation, construction activity. That's what you're looking for, because when those pipes leak, I don't know what the pressure is on the Millennium. Does anyone know? It's probably between 500 and 1,500 pounds. If that pipe has a leak in it, you're going to see it. You're going to hear it. You're probably going to feel it. And that's what happened in San Bruno, California. A transmission line let go in a residential neighborhood, and I think it burned down the whole neighborhood. You know, they're like 30 houses, 40 houses or something. So it's very rare to have that happen. But it can happen.
And you had mentioned that vegetation is affected by the methane, and you showed us a picture of the trees. Do you know how long it takes?
Really depends on the vegetation and the severity of the leak, how much gas is coming out, the duration. So if you have a lot of gas, which totally pushes out all the oxygen, really dries out the soil, it can happen very quickly. On a small natural gas leak, it's going to go very slow, and you're going to get a lot of these methanotrophs in the ground that are slowly consuming up the oxygen. It's a very slow death. So I'm very interested to see what's going to happen out here in areas where we know that there's increased methane levels in the ground. If there's a 1.8 parts per million level in the ground naturally, and you have a certain amount of methanotrophs, what happens when you elevate that to 5 ppm in the ground, or 50,000 ppm, or what we saw in Leroy, we had 950,000 ppm in the ground. That's 95% gas. Now, that was just at a couple of points. We couldn't access the whole area, but I'm very interested to see if I can gain access back there to see what's going on at that property. I know that there's some litigation going on out there with a lot of that property, so I really don't know what's going on with the vegetation, but it'd be interesting to see.
Thank you.
A methanotroph is methane-eating bacteria, by the way.
Can you speak about the difference, if any, between groundwater contamination versus air contamination? I mean, does it make sense to check just the groundwater if you can't check the air?
I personally would not want any methane in my water. And to say that methane is non-toxic, I will say that I have not seen any studies that say that. There have been no studies to say that it is toxic. So it's really, really questionable. What I will say is that if you have methane blowing around, that's raw gas, what's known as raw gas, and that's just come out of the ground. I don't know how long it takes, but we have indications that there's high radon levels in some of this raw gas that's coming out. So I would not want any of that methane coming on into my breathing, into my body. But that's just a personal note. I don't have any data that specifies whether it's okay to have gas in your water and drink it, or
that's not my question. My
or
question
if
is
it's seeping out, or if there's methane in the atmosphere. I would say you shouldn't have that. Now, Bryce might have some other information on that.
I'm just wondering, like, you've tested a large area, an entire town and wide areas. I have, let's say, property, let's say 17 acres. Does it make sense to have our property tested in the air tested versus groundwater tested?
I would do
and
both.
which is the better value and the cost, you know, in terms of costs also, because that's a factor as well. Like if we wanted to test the air on 17 acres, let's say, what would that cost to have that done versus testing for groundwater contamination?
We could actually test both at the same time, and it really depends on the terrain. The water is actually not that complicated a test. You can do that pretty quickly, and with the analyzer that we have, we can detect a minute amount of methane in the water. Very, very small amount. We can detect if there's any in there, as opposed to the tests that are going on now that are going in milligrams per liter. We can detect it in parts per billion. So that water test isn't that expensive. What becomes expensive with testing a parcel, if you said I have 17 acres and I said, well, it's going to cost you $100 an acre. I don't know if you have woods on it, whether it's steep terrain, whether it's open field. If it's an open field and I can mount an analyzer on a four-wheel drive unit, it's very, very inexpensive to do. If you had a wooded parcel of property with a swamp and hills and this and that, I mean, I've been on properties with portable units, and I needed a machete to get through areas. I like to grid it out at about 25 to 50 feet max and go north, south, east, west. So it really depends on the property itself. I mean, you might be able to do a 100-acre field in a lot less time than you can do a 17-acre parcel.
And what about wind, for example? We have neighbors who have cattle on their property. You mentioned that as a source. How much of an effect does that have on testing, let's say, on our property when the neighbors have cattle nearby?
It's a very good question. It really would depend. I mean, if you're right downwind of a number of cattle and we wanted to do the testing, number one, we would probably say, hey, is there a time that we can test when the cattle aren't going to be right there? I would rather do it without cattle right there to change the results, because what we're looking for is a thermogenic source that may be coming, or a biological seep that may be there we can identify. If we did get gas, we could take a sample and run it for isotopic analysis if there was something of real concern. So, yeah, wind would be a factor in the way I would want to do it, absolutely. Yeah, I mean, if you know you have a methane source right next to you, I would wait for a day where I knew the winds were going the opposite way. It'd be a very, very good question.
Let me ask you another question. Have you been involved in any litigation as a result of these baseline tests that you've done?
None. This has just come out as a baseline test, and it hasn't been used that I know of in any court case. So, no, we have not been involved in any litigation.
And is there a minimum or size of property that you would need to be able to come up with some kind of conclusions about the sources of methane in that area?
No, I don't believe so. We can test the ground if the methane's coming out of the ground, we can determine where that source point is on any given property. Now, if the methane's coming from an adjacent property, then you have a problem. Because if you'd have to have access to that property to identify the source if it was coming across.
All right, thank you.
Okay, Dan.
We have some concern in the upper Delaware because the DRBC may be relaxing its de facto moratorium in the near term. And the $9,000 for Delaware, is that, we have 15 townships in the upper Delaware?
Nine, not 90.
No, I thought I said 9, but I was, 9, yeah. Is that kind of a ballpark if there are 13 other towns in the upper Delaware, both sides of the river? I mean, plus minus budget for this activity if we can convince others to do it?
What we'd have to do is understand the actual size that has to be looked at. It costs a lot more to do, for instance, Damascus Township than the town of Delaware because it's about 5 times bigger.
So it's lineal road surfaces?
Pretty much.
Effectively?
Pretty
Okay.
much. It's how many miles
Yeah.
are involved and the roads, how many miles of roads there are. That's a major factor, or the
Okay.
major factor.
Okay, understood. And second question, if you have a baseline, if you don't change like swamps, lakes, septic, landfills, is that baseline kind of solid for a good amount of time? Or what would be the frequency, like the town of Delaware, Damascus, when you'd like to have another baseline done to kind of check or to develop like an overtime baseline, or?
From a most solid possible information basis, I should say practical information basis, you should we know there is seasonal variation. And it really depends on how small of an amount of contamination do you want to be able to detect. If you want to be able to detect a really small amount of contamination, then you're going to need 4 or 5 baseline data sets. On the other hand, if your concern is, if you're willing to say, I think something's going on here, and you've got, let's say, because we typically do these 2 runs, so we have 2 data sets in a baseline. We just prefer to do that to begin with. But those will be usually done on consecutive days or maybe 1 week apart or something. The next time, when you want to go out and you want to see if contamination is occurring, and that's the only thing you have, then you want to try to hit that under roughly the same weather conditions at roughly the same time of year. Because if we were to get you a baseline in summer and run a contamination detection run in January, we're going to be predisposed to a high level in January, just naturally occurring variation. If we were to do the reverse, and in that case we would be saying, oops, contamination. If we were to do the reverse and do your baseline in January and then do a contamination check run in summer, then we were predisposed to miss the contamination because your January baseline is seasonally high. So you can, the ideal way would be maybe get your, a solid baseline would be say 1 in each quarter, 1 each season, and then you can sit on that until there's a substantial modification of some kind in the township. Put in a major septic authority, sewage facility, big feedlot goes up, gas well comes in, compressor station comes in. And unless there's some substantive change, some reasonably large change, it won't really affect the baseline that much.
So I heard you, when you did the one in Delaware, you actually went through it twice to double check yourself?
Yeah, that's really what we do.
Yeah, cool, okay.
The essentially single season baseline, I'm sure the fellows will correct me if I'm wrong, is a very good start. And is pretty reliable in terms of what you have, and then the others are like a check against that. Am I okay?
Yeah, let me just
Okay.
add something.
All right, Bob's going to add to that. And then we have-
On that baseline question, once you have that baseline, if you're looking for a massive change, it's not going to be that hard to see. The variation that Bryce is talking about seasonally is going to be just a couple of thousandths of a ppm difference. So if we do a baseline in summer, we know we know where we're getting some readings that are natural. If we see a new indication of gas, of methane, we'll be able to detect that no matter when we do that survey. So we could do a survey in January or March. I would prefer not to do it in frost conditions, but we can. But we could do it, the seasonal variation that Bryce is talking about isn't going to have that much of an impact on detecting some type of occurrence, okay?
Thank you very much for holding this session. I would like to ask, is this the first public presentation of GIS data or just this town of Delaware data?
This is the very first presentation of an area methane baseline done in New York State. Matter of fact, it's the first public presentation of any area methane baseline done anywhere. We never did a public presentation for the Damascus baseline. And then the next after was that was done was the town of Delaware, and followed by town of Sanford, but this is the very first public presentation of it.
Okay, good, thank you. So, Trish, to follow up with that, I was just thinking, and I don't know how it works, but funding, you might look into if there's any funding available from grant money when you're doing this publicly.
Yes, we have done that, and it's a long story, but
and I'm happy to contribute as I always do, and perhaps increase the amount because of the cost of this and the value of this to us all.
Some of the grants have actually empowered some of these results you're seeing today.
Okay.
But it's not always enough.
Right. Okay. I would like to know from the gas safety, what peer-reviewed journals might we expect to see your work published in?
We've had a couple. Enviroscience, I believe, is one. And you can go on Jackson's site, He did just move from Duke to Stanford.
Oh, yes, I know.
So Rob has all those. Rob was the lead author on Washington, D.C., and Nathan Phillips from Boston University was the lead author on the Boston gas leak study that we did. So Rob has both of those posted on his site that I believe is still up at Duke, but I believe one was EnviroScience. It might have been both of them were EnviroScience, but I can't give you that exact.
Okay, and I've seen some of those papers. Thank you. So a follow-up question to that is there confidentiality in some of the contracts you might have? Is there any work that you're doing that is not allowed to be discussed or presented or published?
I don't think so, not that I know of. A lot of the limitation is just funding, because there's one level of funding to collect data, and then a second level of funding to analyze it and write the reports, and then a third to do presentations and be able to publicize the reports and so forth. So there's like lots of fuss between collecting the data and making the presentations. But the data is collected on public roads, and we are free to do with it as we please. And as far as what gas safety has collected, there's just limitations in terms of funding, from what I understand. Is that true?
Yeah.
Okay, thank you.
So what about insurance companies? Are they interested in this data? I would think they would be.
Well, this is where our I want to say colleague, Elizabeth Radow, who's an attorney and is now going to be working with Damascus Citizens. Her focus has been on mortgages and insurance and gas drilling and the interlocking of it, because the effect on property values and mortgages is tremendous. Matter of fact, anybody with a mortgage is supposed to get permission to sign a lease. This usually doesn't happen. Insurance companies have issued blanket, we're not covering this or that, contamination from this or contamination from that, for people as they re-sign their, sign up for the next year's insurance. So that's a very good question. They should be concerned, because like for instance, that picture over there of the Wyalusing area, that covers about 100 square miles. There's a lot of properties in there, and any property in there that now has methane in the water, that property value is severely lowered. And the insurance companies should be interested, but they don't want to take the hit. So it's a matter of educating, just like everything else. I mean, if they when they start to really realize what's going on, I think there'll be a lot more telling people we're not responsible for this, we're not responsible for that, and it will make an impact. But as of now, it's back and forth.
Thank you.
Thanks. This was so interesting. A couple of questions. Do you have a cost per mile to do this survey, so that we can look at different towns and say, well, this will cost $5,000, this will cost $8,000? Is there a certain cost, like $100 a mile or something?
Right now, we can do it for about $75 per mile.
Okay. And the other question is, you do like federal highways, county, and local. You do all of those categories? Okay.
Sure, we can do any public roadway.
Well, like the roads around here, for instance, are a mix of state road, county road, town road, and it doesn't matter. All of the roads done in any of these municipalities, the main thing is they are public roads. They are not private roads.
Well, in our area, for instance, around Afton, there's an interstate, so it's federal. So my question is this: if this data were to be used in court, is at the federal level, perhaps, is there any implications of the data being withheld because it's on federal property or state? Probably not county or village or. I think there's probably not, but I want to make sure.
I don't have the answer to that question. I would think not, but.
Okay.
I've asked our attorney Jeff Zimmerman, who's an environmental lawyer of long standing, about some, not exactly that question, but he said the main thing is that it's a public road.
Okay.
That was like the base of the baseline. It's a public road.
Thank you very much.
In terms of the compressor stations, how many, around how many have you measured? And to what degree are they heightened in terms of the methane level?
I believe we've only done, what did we do? Just one. We did we did a baseline around Minnesink, and
That was before it went in, and also the Hungry Hill. That's all we've done so far is before.
yeah, and I don't think we had any elevated results around Minnesink. Did we, Bryce?
No, but you didn't do post.
We did not do post.
Yeah.
Right.
They were before, yeah.
Yeah.
There was,
Oh,
what do you want me to say?
oh, okay, I'll.
No, there was no post compressor construction measurements. We haven't been there since.
So there's no possibility of getting the measurements now?
Of course.
There is a possibility we
Yeah.
can go back?
That just brought something to mind. Oh, we did do, this is an aside. I actually asked Bob, because of somebody contacted me, to make a stop on one of his runs over here to Pennsylvania when he's coming from Massachusetts at a compressor station in Connecticut. It is, as nearly as we could tell, I mean, Bob described it as being silent the day he was there. So we don't know whether it was not in operation.
That was in Newtown.
Yeah. And in any event,
It was Brookfield, right next to
in any event, we didn't find any methane around that one, but we don't know if they were down that day. We don't know if they're operating. It was silent, so we don't know if the compressor station just wasn't operating. And impression is that it was an electrically powered compressor station, which puts a whole different spin on things. But that's the only one that we've measured. We've measured sites pre-construction, but that's the only one we've seen post-construction. And that one had been for a long time.
Does that hold special interest for you to go back and focus on that?
What we'll do is, since we have a baseline from Hungry Hill, we have a baseline from Minnesink, and we will be revisiting, and we have this one that with a silent compressor, which probably implies it wasn't on. But we will assemble this data on the Damascus Citizens website under compressors, especially if there's revisit. But like I say, we have to collect the data, and then we have to have funding to have the reports done, which means analyzing literally millions of data points. So one thing, if anybody's interested in even helping us with funding for a very, very smart young person who's helping us with some of these very elaborate computer programs, we have what is Jake, a senior in high school now? A junior in high school, who's like a computer genius, who's working with us. He's done analysis of some of the programs that were supposed to help us but didn't work. And he says, well, I don't really know that computer language, but I fixed it. So, people are willing to help with that kind of funding for him as an intern or something. We need all of this kind of stuff. So whatever your interests are, we can put it to work. And we will post the compressor station data as we can assemble it.
In terms of funding, this really will be the last one. In terms of funding, has there been any thought to asking the EPA or any kind of government?
Well, we have applied to one. We have applied for one government grant, and we are applying for others. The grant process is laborious, and when you apply for a government grant, it's mildly insane because there's like this and then that and then that. Oh, by the way, you have to do this and this and that and then that. But we're doing it, and so we are doing those kind of things. And when you apply for a grant, you can wait 8 months before you hear yes or no. So you just keep putting them out there, and we'll see what happens.
Thanks.
And also, in the answer to your question before about putting them up on a pole, these machines have been put up on 200-foot poles out in Wyoming, it's out west, for a year at a time. and then they analyze the measurements and to see what's going on in a gas field. But, you know, it's not really what we are capable of doing.
Are there any other questions? Okay. I guess we'll wrap it up then, and thank you so much again for coming and being a part of this, and please share this information with your neighbors and friends and other people that are concerned about, you know, the effects of natural gas drilling and how you can do preventative measures by having these tests done.
And don't forget to get your report on your way out, and also anybody who's interested in more of the statistical mysteries of how we handle these mountains of data, come and talk to Bryce, and he has more slides and information to share with you.